Okay kids, now we will be going with this first paper discussion. You can pause and you can read the question. The question says, a cube is made of 6 thin insulating square faces, each square having side D and carrying a uniformly distributed charge of Q. Each square is having a side D and charge Q. Magnitude of electric flux leaving the sixth face due to the electric field of other 5 faces is phi, and magnitude of electrostatic force on each face of the cube is F, right? Okay, before this I think in revision class I have taken like when it is symmetrical situation and yeah, special case, then you can find the force when flux is given, right? So I must have discussed like when point charge and disk is kept, how to find the force between them, right? Now similarly you can try this as a simple example, how you will be finding the force on the plate will turn out to be flux due to this one times charge density on this plate. Anyway, I will be explaining it here. So this is the actual question asked, right? Maybe you can see the hint and you can try. So this is what I have written here. So it is like there is a cube. Now you want to find the flux through this side because of the remaining faces. Now if I take full cube, with 6 faces, if I take full cube, and if I try to find what is the flux coming out of this face, by symmetry you can say like the flux coming out of this face will be 1/6 of the total flux. 1/6 of the total flux. Total flux is how much? Total charge by epsilon naught, right? Total charge is 6q. Each phase is having q. So what is the flux coming out of one phase? It is q by epsilon naught. Flux coming out of one phase will be how much? Q by epsilon naught. Now that flux will be because of two reasons. One is that flux will be because of self flux and because of remaining 5 phases. And due to itself, right? Now due to itself, what will be the flux that you can calculate easily? If I take this phase alone, if I take that phase alone, flux due to that phase on one side will be q by 2 epsilon naught and other side will be q by 2 epsilon naught. So flux due to this phase on one side it will be how much? Q by 2 epsilon naught. But total is how much? Total is q by epsilon naught. So where is remaining q by 2 epsilon naught coming? Remaining q by 2 epsilon naught will be coming because of remaining 5 phases, right? So self flux plus flux because of remaining 5 sides will be q by epsilon naught, and self flux will be how much? Q by 2 epsilon naught. So due to remaining 5 it will be q by 2 epsilon naught. Now what we got? We got what is the flux, right? So if this is the phase we were worried about, now electric field lines will be coming in some random direction because of remaining 5, but what we know by symmetry we can say like net force must be only along this direction. Net force will be only along this direction. So we need only electric field component in this direction. So if we know the electric field component in this direction, on any small element what will be the force? On any small element the force will be dq times of E perpendicular. Now dq you can write as sigma times of dA times of E perpendicular. Now when you integrate this, then you will be getting the net force on this face. Now while integrating you can take this sigma out. When you take this sigma out, you will be getting E perpendicular times dA. This is nothing but flux, right? Flux because of remaining phases will be q by 2 epsilon naught times sigma. That will be the force on the sixth phase because of the remaining, right? Next question, you can pause and you can read the question. A solid uniform iron cube of volume 1 liter is fastened to one end of an ideal string, the other end of which is attached to light plastic bucket containing water. The string passes over pulley an ideal pulley and the iron cube is suspended in water as shown in the figure, fully submerged. It is found that the system is in equilibrium. Water doesn't spill during the process performed in the operations. So you need to mark the correct options, and density of water is 1 gram per cc and iron is 7.8 gram per cc. Now if you look at the options, in all the options we were bothered about like liters only, so we don't have to calculate exact value of weight and stuff. So this is the initial situation, right? So when I draw the free body diagram of the block alone, there will be how many forces? Its weight and buoyancy. Its weight will be how much? 7.8 into V into G. I am just writing like 7.8 instead of V into G because answers are in terms of liters only. So 7.8 into V into G. Now how much will be the buoyancy? Buoyancy will be 1 into V into G. It's kind of like 1 liter weight of water. 1 liter weight of water. The magnitude of force, right? So the magnitude of force, this one is 7.8 liters of water, right? So if this has to be in equilibrium, then tension has to be how much? Tension has to be 6.8. The meaning is tension magnitude wise it must be equal to 6.8 liters of water, right? Now similarly, when you draw the FBD of bucket plus water, how many forces will be acting on bucket plus water? Its own weight plus this 1 liter weight of water, right? This one. Buoyancy is exerted on the body, so it will be exerting the equal amount of opposite force, right? Now tension we got as 6.8, so 6.8 and this is 1, so weight has to be 5.8. So what is the weight of water present? What is the amount of water present? 5.8 liters of water will be present in this situation. Now what will happen when we start pouring a liquid in this? Like there you can imagine a situation like where this need not be inside water, where it's like a simple pulley balancing its weight, this weight. So let us try to find a situation where this won't be in water, it will be hanging in air, but it will be balancing the weight of this beaker plus water. If that's the situation, then both sides weight has to be same, right? So this is 7.8. So the weight of the bucket plus water has to be how much? 7.8. That you can see from this figure, right? When they are independent of each other, they are not touching each other, then this tension must be balancing this weight, this tension must be balancing this weight. From here you can say it must be 7.8. So if this is 7.8, this has to be 7.8, right? So but what we got earlier, it was 5.8 liters of water. So till we pour 7.8, I mean till we pour 2 liters extra from 5.8, when we pour 2 liters extra, till we pour 2 liters extra, what will happen? This cube will start coming up. This cube will start coming up and it will be partially submerged and partially outside. When we pour 2 liters, what will happen? This block will be coming out of the water. It won't be anymore in touch with the water. There won't be any force between water and the block when we pour 2 liters. So till 2 liters, that is, if you look at the options, option B, it says if 1 liter was slowly added to the bucket, then in the new equilibrium condition, cube will be partially submerged condition, right? If you have poured more than 2 liters, they have said like if 3 liter of water was poured, if 2 liter was poured, what will happen? It will be just coming out. If more than 2 liters was poured, what will happen? This weight will be obviously more than this weight, so then this will try to go down and this will try to go up and it will go and hit the pulley, right? It will go and hit the pulley if you pour more than 2 liters. So option 3 is also fine. Now if 1 liter of water was slowly removed from the bucket, so if you are pouring water, what is happening? This is trying to go down and this is trying to go up. So if you remove water, what will happen? This will try to go down and this will try to go up, right? So when this is trying to go up and this is trying to go down, what will happen? At some point of time they will be touching also, right? Okay, and this question I was not getting the answer. Maybe you can ask me after the exam. If I am still not getting it, maybe you can take help of other teachers. Next question, you can pause and you can read the question. The question says, a person riding on a source S of sound frequency 48 Hz moves in a medium with a velocity of sound 310 the source is moving with speed 10. Okay, velocity of sound in reservoir is 1240. a detector D in the reservoir moves towards the free surface. Okay, everything is given in the figure. With 20, the sound produced by source S gets reflected and transmitted at the free surface. Mark the incorrect statements, assuming the liquid in the reservoir stays still and calm, right? So this is the question, and this is how I will be solving it. Maybe if you are solving in the other way, maybe you can try by that way. I will be going with the analogy of kinematics. It's like there is some source which is moving with speed 10, which is moving with speed 10, and it is producing sound of speed 310. So what will happen, let me say, like instead of compressions, I will be visualizing them like balls. So the first ball, the compression will be generated, and that compression will travel some distance, right? After how much time the other compression is generated? 1/48 seconds, right? So during 1/48 second, what will happen? It must have traveled how much distance? 310/48. Okay, I will be doing it here. Source is here, and it has generated some compression. It will be traveling how much distance? 310 into T. Now by the time it has traveled 310 into T, this source must have traveled how much? 10 into T. So what is that difference? That distance is 300 into T. Now it will be now this compression must have traveled somewhere here. Now the new compression is getting generated here. What is the distance between them? Distance between them is 300 into 1/48. So that's the wavelength generated by the source. Wavelength generated by the source. Now the thing is, after what time this compression will be replaced by this compression? This ball will be replaced by this ball. Speed of sound is 310, speed of ball is 310. So, and what is the distance? Distance is 300/48. So you know distance, you know speed. So you can easily say after how much time it will be coming here. After how much time? Distance by speed, right? Now you can say like this ball, it is traveling somewhere here, and this ball is reaching here. So how much time gap? Time gap is this much, right? So in this much time gap, this one must have traveled here, and this one must have traveled here, right? So can you tell me how much distance it would have traveled in this much time? You know the speed, you know the time. You can, okay, speed is not this one, speed is 1240, right, when it goes into the other medium. You know the speed, you know the time. So speed into time. That will give me the distance between two consecutive balls or compressions, right? So when that will turn out to be 25, which is correct, but they are asking us to mark incorrect options. So now beat frequency registered by the person, and that's a direct question, right? So if there is some source here which is moving towards some wall or whatever it is, now when sound is reflected, you will be having your own shortcuts, like you will be imagining like source is moving and image is coming this way, right? And yeah, whatever it is, you can calculate what is the frequency heard by the person after reflection. And okay, after reflection, because of reflection, he will be hearing 51.2, but by his own generation, he will be hearing 48. So what is the beat frequency he will be hearing? 3.2, right? Now frequency of sound detected by detector. So again, so the distance between these two is 25. Now detector is moving with speed 20. So with respect to detector, this compressions will be having speed 1260. Now let me say this detector is catching this first ball. Now what is the distance it has to cover? Relatively, it has to cover 25. And what is the relative speed? 1260. So relative speed is 1260, relative distance is 25. You can calculate the time, right? 1260 by 25, that will be frequency 50.4, right? And last one is kind of theory question, right? Maybe you can refer notes, or you can Google. You will be getting like animations and stuff. Compression pulse incident on free surface due to S is reflected as rarefaction pulse, but that's wrong here. It goes opposite to what happens in light waves. When light waves goes from rarer to denser, they will be undergoing through a phase difference of pi. But sound waves are pressure waves, so they will be going by the exact opposite nature. Anyway, next question, you can pause and you can read the question. The question says, a plano-convex lens has a thickness of 4 cm when placed on horizontal table with curved surface in contact with it. observed from above, the apparent depth of bottommost point of lens is found to be 3 centimeter. If the lens is inverted such that the plane surface is in contact with the table and observed from above, the apparent depth of the center of the plane face is found to be 28 by centimeter. So you need to consider only paraxial rays, and you need to find some stuff. Let us find. So they have given two situations. First situation, second situation, and it is not a thin lens, it is thick lens. It is thick lens. Now there is some point here you are observing from the top. So what will happen? The light which is coming from that point, it will be undergoing only refraction here, right? So you know, like when the object is here and there is a flat surface, you will be feeling like there is a little rise in the image. So you can go by apparent depth, real depth, however you have learnt it. How I will be doing it is, I know it will be shifting little upwards, which will be less than 4, so 4 by mu. That is given as 3 in the question, so mu value will turn out to be 4 by 3. That is the first case, first condition. From first condition I will be getting mu value. I will be using that mu value here. Now you are keeping some point here. Now light from that will be undergoing through refraction through this curved surface. So refraction through curved surface is mu r by v minus mu I by u equal to mu r minus mu I by r, right? So incident ray direction is this way. So distances you will be measuring from this pole. So object distance is minus 4, image distance is minus 25 by 8, and radius of curvature is also negative, right? So from here when you calculate, you will be getting radius of curvature is 25. Now comes the other two questions. Power, optical power of the lens. Optical power of the lens says converging capacity. Now if there is a thin lens with one side flat and one side some radius of curvature, maybe let me say 25, and if there is a thick lens, radius of curvature 25 and one side flat. Now power of these two will be same. The meaning is converging capacity, because converging capacity will be happening only at this curved surface, right? Now that whatever thickness, whatever extra thickness, maybe instead of drawing this way, let me put it, okay, let me go with the other example. Maybe I can say, like, if there is a thin lens, thin biconvex lens, or if there is a thick in the sense it will be having some thickness, right? There is a difference. This is thick lens, this is thin lens. Now converging will be happening only because of this refraction at this surface and refraction at this surface. So converging will be happening because of refraction at this surface and refraction at this surface. So power of this structure and this one will be same. Converging capacity depends only on these two curved surfaces. But focal length of this one and this one won't be same. And at the same time, if the radius of curvature is different, or like, yeah, if the radius of curvature is different or depending on the outside medium and stuff, if you are sending parallel rays here, it may be forming image here which will be this focal length, first focal length. And if you are sending parallel rays from this side, image will be formed at some other distance. Maybe let me say, if this is 25 centimeter, this doesn't have to be 25 centimeter, it can be 15 centimeter depending on situation. Maybe you can try out for this question. You can try out taking this lens and send the parallel rays and see where the image is getting formed. Similarly, send the parallel rays and see where the image is getting formed, and check whether in both the cases focal length is same or not. Most probably you won't be getting same. I think that's the reason they made the question. So focal length of thick lens need not be same when you are sending the rays from different sides, right? But power doesn't depend on the thickness. So you can say, like, power is just nothing but kind of power of thin lens. Now focal length of thin lens doesn't depend on from which side you will be sending the rays. So power of thin lens doesn't depend on from where you will be sending the rays. So if power of thin lens doesn't depend on from which side you are sending the rays, power of thick lens also won't be dependent on from which side you will be sending the rays, because power depends only on converging surfaces, not on the thickness. But that's kind of weird question to ask, because in all our books it won't be mentioned, like NCERT or HC Verma, because we will be dealing with only thin lens generally, because thin lens is only like useful instrument for us, right? So for thin lens, focal length and power both doesn't depend on from which side you will be sending the rays. Obviously thin lines in the sense outside medium will be same. Next question you can pause and you can read the question. The question says, an amount of water is poured on top circular face of horizontal glass cylinder. Excess amount of water spills over the edges of, and a little amount of water remains in the thin uniform layer, a portion of which is shown in the figure. If the contact angle is theta and the surface tension of water is sigma, the vertical thickness of water layer far away from the edge is T, and the point in the plane of the diagram on the liquid where the liquid protrudes the most is capital D. The vertical depth of this point from the horizontal free surface of the water layer is D. Rho is density of water, G is acceleration due to gravity. Mark the correct relations. And if you have seen PG Kesar's revision video, I think he has taken this question. So there must not be much difficulty in solving at least one of the option. So this is what PG Kesar has done in the revision video. He has drawn the free body diagram of this small part, and he is will be bothered about only horizontal forces. It is in equilibrium. That part is in equilibrium. So net force along any direction has to be 0, but we will be bothered about only horizontal force because vertically there will be like other normal reaction and stuff forces. So horizontally there will be surface tension force here. Now we are taking a small element of length dl. That element is into the board. Small element, right? The element, if you zoom, it looks like this. That is into the board. Now on this one, that small element, there will be surface tension force here, right? It is TDL, and here it will be in this direction TDL, right? TDL and TDL. Now this angle is given as theta. Now apart from that, from outside pressure is P naught. So from outside the force will be pressure into effective area. Effective area is how much? This length is dl and this length is t, right? This length is t. So dl times t, tdl, right? Now similarly, what will be the force from this side? This pressure is P naught, this pressure is P naught plus rho gt. So you can go with integration, or you know the well known result, average pressure times effective area. Average pressure is pressure at the top plus pressure at the bottom by 2. Pressure at the top plus pressure at the bottom by 2 times effective area TDL. Now these are the only forces acting in horizontal direction. Net force has to be 0 along horizontal direction. Resolve this one will be how much? TDL cos 180 minus theta, right? So TDL plus TDL cos 180 minus theta equal to this minus this, which will be rho gt by 2 into TDL. From there you can solve it, you can get T. Right, now apart from that, they are asking other thing also. What is that other thing? The maximum extension here is at this point, which is at a depth d, So obviously we have to draw the free body diagram for this part. Now proceeding in the same way, when you draw the free body diagram for this half part and this part till that maximum extension is there, right? So again, when you draw the FBD and when you look at the horizontal forces, the horizontal force will be TDL, horizontal force, and apart from that there will be pressure forces. Remaining all will be vertical. I am not bothered about them. So net force must be 0. When you do it, you will be getting the required answer. Next question, you can pause and you can read the question. The question says, Anushka is sitting on the edge of a horizontal merry-go-round that has a radius of 6 meters and is rotating steadily. Virat is standing still on the ground at a point that is 12 meters from the center of merry-go-round. Assume their line of sight is horizontal. At a particular instant, Virat observes Anushka moving directly towards him with a speed 1 meter per second and observes there is no component of velocity perpendicular to the line joining. I think you can read the question. I will be just showing the figure and explaining the question. So you can see someone took the question from here, and yeah, obviously cricket fan, Virat Kohli and Anushka. From the given information, you can figure out the situation is like this. It's like Anushka is here, and it is merry-go-round is rotating with omega. And Virat is seeing. Okay. Virat observes Anushka moving directly towards him. Virat is okay. Forget about the remaining stuff. So Virat is seeing that Anushka is moving with speed 1. This length is reducing at a rate 1. That's what Virat is observing. Right. But at the same moment, Anushka observes Virat to be moving with a speed root n. That's what they are saying. And you have to find other stuff also. At the same moment, the rate at which Anushka observes, the distance between them is decreasing. The distance between them will be decreasing. Both will be finding the same thing, right? Virat will be feeling the distance between them is decreasing at a rate 1, or Anushka also will be feeling the distance between them will be decreasing at a rate 1. Now, what is that extra thing coming into picture? At the same moment, Anushka observes Virat's velocity perpendicular to the line joining to them. Now, this is the important point of the question. Why Virat won't feel any perpendicular component for Anushka, but why Anushka will be feeling perpendicular component to Virat, right? Before understanding that, maybe you can look at this picture. I am rotating this one with omega, and I am rotating by 90 degrees. When I am rotating by 90 degrees, what will happen? Look at this structure. This structure is like, okay, maybe let me say it's like, okay, it's like this. Maybe it is, yeah, fine. So the name looks, the name is visible to you. The name is visible to you. Now, when I am rotating it by 90 degrees, the name will be like going on to this side, right? Earlier it used to be facing towards you, but it has rotated 90 degrees now, right? So what you can do, you can visualize this motion as combination of two motions. What are those two motions? Curvilinear motion of center of mass. Curvilinear motion of center of mass meaning like this name will be always visible towards you, right? This name is always visible towards you. Now, curvilinear motion of center of mass is finished and rotation about center of mass, right? So, when you are rotating the disc, when you are rotating the merry-go-round by 90 degrees, you can try to visualize the motion of Anushka as center of mass curvilinear motion plus rotation about center of mass. Now, how much angle she is rotating about center of mass? It is 90 degrees, right? So, whenever merry-go-round is rotated by 90 degrees, Anushka is rotating by 90 degrees. Now, you can try to see it by 180, 270, any angle. After that, you can figure out Anushka's motion, you can visualize as curvilinear motion of center of mass of Anushka plus rotation about center of mass, and that angular velocity will be how much? Same as angular velocity of the merry-go-round. Now, that's the crux. So, you can visualize it like PQRS. Generally, when you rotate, P will be like initially which is looking here, now it will be looking on to this side. Now, the same thing you can visualize it like curvilinear motion of center of mass, where P will be pointing always towards you and rotation about center of mass, right? So, the same thing when you apply here, Anushka is rotating about herself, right? Curvilinear motion of center of mass and rotation about center of mass. So, when Anushka is rotating about herself, then she will be feeling, when Anushka is rotating like this, she will be feeling like the entire world is rotating in the opposite direction, right? So, the line joining, she will be feeling it will be rotating with angular velocity omega, and this distance is 6 root 3. So, what is the velocity of Virat she will be observing perpendicular to the line joining? R omega, right? I think remaining things you can find. This is given as like this distance is 6, and from here 6 omega is 1 given in the question. You can find omega, you can substitute omega, you will be getting all the required things. So, Virat will be feeling Anushka is moving with speed 1. Anushka will be feeling Virat is moving with speed 1 in this direction, and perpendicular component is root 3, right? Next question, you can pause and you can read the question. The question says, a small spherical ball obeying Stokes' law for viscous force is thrown up vertically with a speed 20 meters per second and received back by the thrower at a point of projection with speed 10. Neglecting the buoyant force on the ball, assuming the speed of the ball during the flight is never equal to its terminal speed and acceleration due to gravity as 10, what is the time of flight of ball in seconds? And this question has appeared in some of your exams here already. So, throughout the motion, how many forces will be acting on it? There will be two forces. One is weight and the other one is viscous force. Weight I can write in vector form like m into g bar, where g bar represents the direction of acceleration due to gravity also. So I'm not bothering. I could have written like g in minus j cap, but I'm not bothered. So weight in vector form and viscous force in vector form, it will be opposite to velocity, right? And it is obeying Stokes law. In Stokes law, it will be proportional to v, right? So net force equal to mass times of acceleration, right? Now I will be modifying this equation with, I will be multiplying the dt and I will be integrating it, and most probably this will help whenever you want to find the distance, because distance or time you could modify, because you have seen like this question, and apart from this question you have seen one magnetic field question where you will be finding the distance by the same method, distance traveled by the same method. So after integration vdt gives us the displacement, but what they have given in the question, a person is throwing the ball and he is receiving it back, so displacement is 0. vdt will give us displacement which is 0. Now m into g bar is a constant, so it will simply turn out to be integration of dt, which will be total time. Now m into a bar dt will give us change in velocity will be final minus initial. Now if I take downward direction as minus j, then final velocity is minus 10 j cap, initial velocity is 20 j cap. So from there you can get t equal to 3 seconds, right? Next question, you can pause and you can read the question. The question says, a moving neutron is about to collide with a stationary singly ionized helium atom of mass 4m in ground state. The speed of the incident neutron is equal to minimum speed required such that the collision may be inelastic. So let us try to see till here. So the speed of incident neutron is equal to the minimum speed required such that the collision may be inelastic. So if the collision is inelastic, where is that mechanical energy loss will be going? That will be going for excitation, right? So minimum excitation energy needed for helium ion, how much it will be? Minimum excitation energy needed for helium ion will be 10.2 times 2 square. 10.2 is the minimum energy needed for hydrogen, right? And it will be z square, like energy will be z square by n square form, right? So z square will be 2 square. So this is the minimum energy needed for helium to get excited. So that must be the energy lost, mechanical energy lost during the collision. What is the mechanical energy lost during the collision? Inelastic collision, half m1 m2 by m1 plus m2 into u square, right? Perfectly inelastic collision. Now yes, so the mechanical energy which can be lost, the maximum which can be lost is this much, that must be equal to the minimum excitation energy. From here you will be getting half mu square equal to 5 times 10.2. I could have calculated, but I just left it there. So that's the part till inelastic. So basically what we did, we found what is the speed with which incident neutron is coming. So we got some information. This is the speed with which incident neutron is coming. Now we will be using that information in the second part. What is the second part? If the collision is head-on perfectly elastic, then the energy of neutron after collision. So basically now they have given the first information to make you to find what is the speed of the neutron. Now second question is quite easy. You know the speed of the neutron before collision, you have to find what is the speed of the neutron after collision. Now this is the question. Okay, I'm just keeping u as u itself. I will be substituting it back in the end. So if it is coming with speed u and if it is hitting 4m and perfectly elastic, then what will be the velocity of, then the energy of neutron. So you need to find what is the energy of the neutron after collision. Now you can solve it by yourself from ground frame. Generally you will be doing it from ground frame, and I will be doing it from center of mass frame. The center of mass of this system is moving the speed u by 5. When I observe from that frame, I will be feeling this velocity is u by 5 and this velocity is 4u by 5. Momentum must be 0. Now after collision they will be reversing their velocities. Velocity of approach must be equal to velocity of separation. So this will be u by 5, this will be 4u by 5. Now again when I go back to ground frame, I need to add u by 5. So 2u by 5 and 3u by 5, right? So what is the energy? What is the energy of the neutron finally? Half m into 3u by 5 square, which will be 9 by 25 times of half mu square. Half mu square we have already calculated initially. I will be just substituting it back, right? That's the required answer. You can pause and you can read the next question. The question says, a light rod connects two particles A and B of mass m each, of mass m each, and a third identical ball particle forms an equilateral triangle with side L with the rod. The particle is given a velocity v0 perpendicular to the plane of the triangle, and rod is simultaneously released from rest. The minimum value of v0 for which the particle will not be bound by the gravity to A and B is. So, it is like you are giving some velocity to it, and at the same time, till then you are holding it. When you have given some velocity to it, you are leaving it. Now what will happen? Obviously, you know, like both will be moving with time. With the time, both will be moving because of their mutual gravitational force, right? Now, when it is, if it is not going to be bounded, the meaning is like they will be going to infinity, right? So this structure will go as it is. So the potential energy between A and B won't be changing. So I won't be bothered about what is the potential energy between A and B because it won't be changing anymore. Now, I'll be solving the question from center of mass frame. The reason is, I think this derivation I must have taken in revision, I am not sure, but kinetic energy will be summation of all kinetic energies. Kinetic energy of the system is summation of all kinetic energies of the particles. Now, when you write particles velocity as velocity of particle in center of mass frame plus velocity of center of mass, and when you expand it, you will be ending up with the result kinetic energy of the system equal to kinetic energy of center of mass plus kinetic energy about center of mass. Now this kinetic energy about center of mass will be half m1 m2 by m1 plus m2 into v relative square if there are only two particles. If it is a rigid body, it will turn out to be half IC into omega square. But we are dealing with kind of like only two particle system, right? I mean, one is m, the other one is like mass 2m. I can visualize that way, right? This is the kinetic energy in center of mass frame. I am not bothered about what is the energy of center of mass, because energy of center of mass won't be changing. You can't use this energy for anything because velocity of center of mass is fixed. What is the velocity of center of mass here? In this question, velocity of center of mass is v0 by 3. Velocity of center of mass is v0 by 3. So velocity of center of mass will be v0 by 3 forever. You can't use that energy. You can't use that part of kinetic energy. Out of total kinetic energy, you can't utilize this part for anything. You can utilize only this part. Now, how much will be this part? This part will be half m1 m2 by m1 plus m2 into v square. So you can utilize only this part of kinetic energy, and you need to utilize it to break that potential barrier, right? So potential energy of this with respect to these two. So minus gm square by L minus gm square by L. I am not bothered about potential energy between A and B because it won't be changing, right? If total energy turn out to be 0 in center of mass frame, then it will be unbounded, right? Greater than or equal to 0. From here we will be getting the required answer. Next question, you can pause and you can read the question. The question says, a charged isolated air gap parallel plate capacitor of capacitance 2 microfarad discharges with time constant 4 microseconds upon interaction of homogeneous dielectric material of dielectric constant 2 in its gap. What would be the time constant for the discharge if the same capacitor not only has the above said dielectric but also resistance of 2 ohm connected across its plates? So there are two situations like regular problem. What are those two situations? These are the two situations. In the first situation, they are saying there is some plate, parallel plate, and you are keeping some. Now, when there is parallel plate, like there won't be any leakage current, but when you keep some dielectric, what will happen? Charge can leak, right? Charge can leak. Now you can see like because of the potential difference, charge is flowing, charge is leaking. So you can try to visualize like this is kind of like a resistor, right? So there is capacitor and resistor, and the potential difference across capacitor and resistor both are same. So you can try to visualize this figure like capacitor and resistor parallel to each other, potential difference is same. Now in the next question, they are saying like apart from this, you are having some extra resistance connected. extra resistance connected, right? Extra resistance connected, which is 2 ohm. So this is the first figure, this is the second figure. Time constant in the first figure is R into C, R into Kc, which is given as 4 microseconds. Now in the second case, R equivalent into Kc, R equivalent, they are parallel, right? So R equivalent into Kc, which is given as, which you have to find. So from here you can get R equal to 1, you can just substitute it back, then you will be getting the required answer. All you need to do is understand there are two situations, draw the two figures, write the two equations, two unknowns will be there, get them. Next question, you can pause and you can read the question. The question says, two uniform rods AB and CD, each of length L and mass M, are attached to two gears which are disc pivoted to fixed points A and C at same horizontal level. As shown in the figure, the system is in vertical plane. When rod AB is slightly rotated by small angle, the rod CD rotates in opposite sense. That you can see. When you are rotating this rod, when you rotate this rod, then what will happen? You can see like this gears, this disc will try to rotate this way. This disc will try to rotate this way. When this disc is trying to rotate this way, it will be pulling this disc in this direction. It will be making this disc rotate in clockwise direction, right? So because of that, this rod will be coming into this position. If I draw that structure here, it looks like this. When you are rotating this rod by angle theta, now this will be rotating by angle 2 theta, right? Because the distance traveled by that point of contact will be same. The distance traveled by that point of contact is how much? 2r into theta. That must be 2r theta here also. How? So 2r into theta is the distance traveled by that point on the bigger gear. Now that must be same as distance traveled by the second gear, right? So how much angle it has to rotate? It has to rotate angle 2 theta. So this rod will be coming into this position where this angle is how much? 2 theta. Right. So when you are rotating this direction, this will rotate in this direction. When you rotate by angle theta, this will be rotating by angle 2 theta. Now when you leave it, what will happen? Torque due to this weight. Now when you take torque about this point, there will be torque due to friction here and torque due to weight here. Now similarly, when you calculate torque for this disc about this point, there will be torque because of this weight and there will be torque because of friction here, right? So this friction will try to pull the bigger disc, rotate the bigger disc in clockwise. At the same time, its weight will be trying to rotate it in the anti-clockwise direction. Similarly, friction on the smaller disc, I can't call it as friction. Maybe I can say like the contact force between them. So the contact force between them will try to pull the smaller disc in the clockwise direction, but its own weight will try to, this rod weight will try to rotate it in the anti-clockwise direction, right? So we'll be writing torque equal to I alpha for both the cases. If you want to go with energy method, you can look into the given solution. If you want the force method, maybe you can try to check out my solution. So if you look at the equation, the first equation I have written for a bigger disc. For bigger disc, torque due to this force, I am calling it a small f. Torque due to this force will be 2r times f. 2r times f in the clockwise direction. Now similarly, torque due to this weight will be how much? L by 2 sin theta. Sin theta will be, theta is small, so sin theta will be almost equal to theta. So L by 2 theta into mg, right? This is torque due to that friction force, that contact force, and this is L by 2 theta into mg, that is torque because of its own weight. That equal to I into alpha. Now alpha is nothing but double differentiation of theta, right? The angle rotated here. Now similarly, when you write torque for this one, torque due to its own weight will be L by 2 sin 2 theta, L by 2 sin 2 theta, which will be L by 2 into 2 theta, L by 2 into 2 theta into mg, torque due to weight, minus torque due to that contact force, which will be F into R, that equal to I into alpha. What is alpha? Alpha is double differentiation of this theta, right? So 2 theta double dash, theta double dash. Now there are two equations, so you can modify them. The unnecessary thing is the contact force, so you can eliminate that contact force. Then you will be ending up with this equation. You can modify this equation and you can get into SHM form. Double differentiation of something equal to minus omega square into that thing. So you can get the time period as 2 pi by omega, right? The other two questions are kind of math questions, maybe you can try yourself. I am not that good at explaining math stuff. A regular tetrahedron Y-frame, okay, anyway you can pause and you can read the question. The only thing what I need to say here is, because of symmetry, if this current is A, then this current also will be A. Now if incoming current is N, then this current will be A, this current will be A. This is how I will be teaching. Maybe if you have referred revision class, you must be knowing what I am doing here. Now this potential and this potential will be same, so no current will be flowing through this CD. Now that's the only major physics part here. Thereafter it's more about math. Maybe yeah, you can try yourself, or maybe like you can check with maths teacher. I have a solution for this question. Maybe if you need, you can text me. I will be forwarding the solution. But still you have to do the major stuff there. And the next question is also, it's also again the math thing, like coordinate axis not perpendicular to each other. You can try by yourself. If you are not getting, then we will see it in WhatsApp, right? Thank you. Okay, now we will be going with the second part. You can pause and you can read the question, and that's a kind of direct question. In the plano convex lens of focal length f, if the plane side is silvered, it behaves like a, okay, you need to get it. So if it's given as r is the radius of curvature of plano convex lens and mu is the refractive index of the material of the lens. Right? There is no single way of solving it, and so generally like I used to go by this way, or like I will be sending, I prefer two ways, one of these two ways. One is like I will be sending parallel rays and I will be seeing where is the image getting formed, or the other way is I will be seeing where I need to keep the object so that image will be formed there itself. So if the image is forming there itself, the rays will be retracing the path. The meaning is the rays will be hitting the mirror perpendicularly. If I am sending the ray like this, and if it is hitting the mirror perpendicularly, it will be retracing the path. So if I keep the object here, then the image will be formed there itself. This is kind of the ray diagram, right? Now I can see like what happens when the rays are coming perpendicularly. I can use refraction at the curved surface formula, mu r by v minus mu I by u equal to mu r minus mu I by r. When I substitute them, rays are coming parallelly, so you can take the object distance as infinity, image distance is v, and you can substitute the remaining thing, then you can get v equal to r by mu minus 1. So that's kind of, if it behaves like a mirror, then the radius of curvature, because if it behaves like a mirror, you need to keep the object at radius of curvature center, right? So that image will be formed there itself. So this is kind of radius of curvature of effective mirror, right? Radius of curvature of effective mirror. Now apart from that, they give other information. Focal length of lens, 1 by focal length of lens is mu minus 1 into 1 by r. So focal length of lens is r by mu minus 1. By using these two, this is the radius of curvature, so focal length will be half of this. Now yeah, you can use focal length of lens is r by mu minus 1, right? So focal length of mirror is half of focal length of the lens. You can do by any other way, like you can send the rays parallel and you can see where is the image getting formed, or you know your own method of being taught in the class, or maybe you can try out something similar to this also from the question from the other day, like right, symmetry thing. You can pause and you can read the next question. The question says, the intensity of an electric field depends only on the coordinates x, y and z as follows. E equal to something. The electrostatic energy stored between two imaginary concentric spherical shells of radii small r and 2r with center at origin. So this is the given electric field equation. Now how you will be seeing it is vector by its magnitude. I am writing like this one, like vector by its magnitude, so that I can see like this is a unit vector, and the remaining terms I am writing here. So this is a unit vector. Now I am calling xi cap plus yj cap plus zk cap is r bar, that is position vector, right? Because if this is origin, position vector, if position vector will be given by xi cap plus yj cap plus zk cap, then this will be r cap, right? Unit vector r cap, and this is r square, right? So electric field will be this much, and you can see like it is spherically symmetrical, right? So when they are asking to find the energy between these two shells, where this radius is capital R and this radius is 2r. Now what you need to do, you need to take some element you need to take some element here and you need to find the energy in that element. What will be the energy in that element? Half epsilon naught E square into dV, right? Energy per unit volume into the volume of that element. Volume of that element will be how much? 4 pi x square dx, where this length is x and the thickness will be dx, right? So when you integrate it from capital R to 2R, you will be getting the required answer. Half epsilon naught E square, E we have already calculated, A by R square, so E square will be A square by R power 4, dV is 4 pi x square dx. Now when you integrate it, I mean instead of x, I substitute smaller, right? So when you integrate, you will be getting the required answer. Next question, you can pause and you can read the question. The question says, a man is running up an inclined plane making an angle theta with the horizontal. With a speed v0, raindrops are falling at an angle alpha with the vertical. Appear to the man as if they are falling at an angle 45 degrees with the horizontal. Magnitude of speed of raindrops is. So that's the question, and again there is no single method to solve this question. I will be going by this way. I will be resolving every velocity given into two mutually perpendicular, that too especially I will be taking mostly like this as horizontal and this as vertical, my x-axis and y-axis. So rain velocity is given. I am assuming rain will be having some x component capital X and y component capital Y, but I know the relation between them. What is the relation? Tan alpha equal to x by y, tan alpha equal to x by y, which I will be using it later. Now similarly, this velocity, man's velocity is v0 and his horizontal component will be v0 cos theta. C1 represents cos theta, S1 represents sin theta, v0 cos theta, v0 sin theta. Now with respect to man, what will be the velocity of the rain? With respect to man, this is velocity of the rain with respect to ground. So velocity of rain with respect to man will be this velocity. Apart from this velocity, apart from x and y, there will be extra components coming into picture, v0 cos theta and v0 sin theta, right? v0 cos theta will appear and v0 sin theta will appear. So this is the velocity of the rain with respect to man, and they said the resultant will be making an angle 45 degrees with the horizontal, and they didn't say whether with this horizontal or this horizontal. So I took two cases and I solved. I took with this horizontal. When I took with this horizontal, the resultant x will be x minus the resultant x component will be x minus v0 cos theta 1, x minus v0 cos theta 1, that must be equal to y plus v0 sin theta 1, because it is 45 degrees, right? Tan 45 is 1. So these two must be equal in magnitude, right? So when you solve it, you will be ending up with the required answer. And I calculated x by sin theta 2. Why I calculated x by sin theta 2? Because we need to find this velocity. So this velocity will be how much? Velocity sin theta is x. So if you want to find velocity, it will be x by sin theta 2. I mean sin alpha. X by sin alpha. X by sin alpha you need to find. That will be fine. Now in the other case where I have taken like it is making 45 degrees with this horizontal, then v0 cos theta 1 minus x, that must be equal to y component. When you solve it, you will be getting other equation, but there is nothing in the option, so I kind of left it. Next question, you can pause and you can read the question. The question says, suppose that the position function for a particle is given as r bar equal to xi cap plus yj cap. It is going in 2D, right? Yeah. The ratio of magnitude of average velocity during time 2 to 4 seconds. So you need to find average velocity during the time interval 2 to 4, and you need to find magnitude of speed at t equal to 2. So you need to find two things and you need to take the ratio. This is given in the question. So if I want to find the average velocity, what I need to do? I need to find displacement during the time interval and I need to divide with the time taken, right? So x coordinate, y coordinate. Now x coordinate at t equal to 2 will be 3, y coordinate at t equal to 2 will be 3y2. X coordinate at t equal to 4 will be 4 plus 1 5. Y coordinate at t equal to 4 will be 3. Now what is the displacement? Displacement is 5 minus 3, 2y cap, 3 minus 3 by 2, 3 by 2 j cap. So this is the displacement in how much time? In 2 seconds, that is from t equal to 2 to t equal to 4. So displacement by time taken, that will give us average velocity in vector form. So if you want to find the magnitude will turn out to be 5 by 4. This is the average velocity. Now you have to find other thing also, instantaneous speed at t equal to 2. right? So x coordinate, y coordinate, velocity along x axis, velocity along y axis. So the resultant velocity will be root of x square, root of vx square plus vy square, which will be root 5 by 2. You can take the ratio and you can get the answer. Next question, you can pause and you can read the question. The question says, in the given circuit, if the switches S3 and S4 are open, keeping S1 and S2 closed, the value of current I through the AC component of the box is I0. That's the first case, right? So for the first case, the figure looks like S1 is closed and S2 is closed, remaining all are open. So the figure will look like this. And in this one, it is DC. So, and if the current is flowing, yeah. So at later time, like it will be E0 by R, right? If there is capacitor, it will become open circuit, but current is flowing. So either there must be resistance plus inductor or resistance alone, right? But whatever it is, after a long time, even if there is inductor, the current will be E0 by R. Now in the second case, if the switches S1 and S2 are open, keeping S3 and S4 closed, the value of I is I0 sin omega t. So in the second case, when S3 and S4 are closed but S1 and S2 are open, the circuit will look like this, and it is AC circuit. In AC circuit, the current will be, maximum current will be given by E0 by Z. And the important thing is, it is in phase also, right? Current is in phase, at the same time magnitude is E0 by Z, and which is same as earlier magnitude. So from this you can easily conclude there is only resistor in that AC component, there is only resistor. So Z will be equal to R, because there is no phase difference, and magnitude wise it is same as earlier magnitude maximum, right? Now comes the third case. In the third case, now if the switches S1 and S4 are open, keeping S2 and S3 closed, the value of RMS current through the AC component during one complete cycle. So in the next case, the figure will look like this. Here you have AC component plus AC source plus DC source. So you can write the loop equation, that will be the ideal way. Loop equation, E0 sin omega t plus E0 minus I into R equal to 0. So I will be E0 by R plus E0 by R into sin omega t. Now you need to find RMS current. How you will be finding RMS current? RMS in the sense root mean square. Root mean square. Mean square in the sense average of squares. Root of mean of squares. So what I will be doing? I will be finding mean of squares first, average of squares. So for finding average of squares, what I will be doing? I will be finding I square. Thereafter I will be finding average of I square. Average of I square is average of the right hand side term. Average of right hand side term is average of this one. Average of 1 is 1. Average of 2 sin omega t will be 0 in a full cycle, because it will be, right, this one and this one will get cancelled, right, in a full cycle. But average of sine square will be half. Sine square plus cos square is 1. Average of sine square and cos square must be same, so they must be half. Anyway, you know that thing. So average of this thing is 1 by 2, average of this thing 1, 0. So this is I square average. I square average. Now that is I square average in the sense mean square, mean of squares. Now you want to find root mean square, root of mean of squares, which will turn out to be root 3 by 2 I0. Next question, you can pause and you can read the question. The question says, in a radioactive decay, A is converting into B and B is converting into C. It is given that T equal to 0, nuclei of B and C are not present. Decay constant of for A to B is lambda 1 and decay constant for B to C is lambda 2, and take lambda 1 equal to 5 lambda, lambda 2 equal to 2 lambda. The time after which B will have maximum number of nuclei is in the form of log 5 by 2 by B naught lambda, then the value of B naught will be, right? And this is one regular thing which I will be showing every time whenever this kind of question is coming, right? So there will be some integration factor, this you have to do, but if you know the result will be of this form, you can get it back. That's what generally I will be doing. It's like, these are the three equations, right? A is decaying, so dNA by dt will become minus lambda 1 into Na. This equation you can write. Now formation of B depends on two factors. One is how, at what rate A is decaying, at what rate B is decaying. Formation of C depends on only at what rate B is decaying, right? So these three equations you can write, and after that you can solve using that previous thing, previous slide, and thereafter you will be getting that equation. That's fine. Okay, I will be showing like After you get this equation, this is the equation we need to get, right? After getting this equation, we need to see when NB will be maximum. When NB will be maximum, when it becomes maximum, its first differentiation will be equal to 0. If its first differentiation is becoming equal to 0, how it looks is NB from that slide will be getting this much. So first differentiation will be, okay, NB will be this much. So first differentiation must be 0. So when you differentiate it and make it equal to 0, and when you solve for it, you will be getting the required time needed. But I'm just showing, I'll be just showing like how I'll be getting this result back. Maybe like those who are bad at this integration factor, maybe, but still it's going to be lengthy, my method. So it's better to go by the traditional method if you know how to do it, or else this is a regular kind of equation. So you know the solution will be Na equal to N0 into e power minus lambda t. Now apart from that, I'll be knowing, because I know the result will be of this form, a into e power minus lambda 1 into t plus b into e power minus lambda 2 into c plus c form, this form. Now I'll be using the initial condition at t equal to 0. Okay, I'll be using the final condition. After a long time, b won't be there because b is decaying into c, right? After a long time, number of nuclei of b will be 0. So 0, and when you substitute t tends to infinity, this will be 0, this will be 0, and c. So from here we can get c equal to 0. Once you get c equal to 0, then I will be just substituting and I will be writing the new form of the equation. It will be of this form. Now at t equal to 0, this one will turn out to be a, this one will turn out to be, this one will turn out to be a, this one will turn out to be b. So 0 equal to a plus b. From here I will be getting b equal to minus a. Again, when I substitute it back, the equation will turn out to be this form. Now I have only one variable to find out, that is a. Now what I will be doing, I will be finding, I know NB, so I will be finding NB dash. The reason why I am doing this is because I know this equation, I know NA, I know NB also. If I substitute NB dash, then I will be getting one equation. I know NB, I know NB dash, I know NA, and I will be substituting it here, so that I will be having one equation and one variable A. So I found NB, NB dash, and I substituted it back. I substituted NB, NB dash, and NA in this equation, right? After that, when I solved it, I will be getting something into x. Okay, this e power minus lambda 1 into t, I have written it as capital X. E power minus lambda 2 into t, I have written it as capital Y, because so that I won't make mistake or I can save time. So this has to be 0 at any time. This is e power minus lambda 1 into t. This equation has to be 0 at any time. So that can happen only when then the coefficient is becoming 0. When will the coefficient become 0? When you solve it, you will be getting a equal to lambda 1 n naught by lambda 2 minus lambda 1. So a I got, when I got a, I can substitute it back, so that I will be getting NB. So this is NB. After that, again it goes this way, NB dash, make it equal to 0, get the answer. Next question, you can pause and you can read the question. The question says, a system of two planks and a sphere of radius r is in motion as shown in the figure. Radius of the sphere is capital R and there is no slipping anywhere. It is given that r alpha equal to 2a naught, where alpha is the angular acceleration of the sphere. Lower plank is having an acceleration a naught. It is given that the acceleration of the upper block is k times of a naught. So you need to find what is the value of k plus 2. So there is nothing much physics here. It's only about like common sense or logic, right? So what I did, I assumed sphere is moving in, sphere is having an acceleration a, and they have given angular acceleration alpha. So the bottommost point of the sphere will be having a minus r alpha, and the topmost point of the sphere will be having a plus r alpha. Now if there is no slipping between this sphere and this plank, then a minus r alpha must be equal to small a naught. And if there is no slipping between this plank and this sphere, then capital A plus r alpha must be equal to small a1. Small a naught equal to capital A minus r alpha. Small a1 equal to capital A plus r alpha. Two equations, and they have given r alpha equal to 2a naught. You can substitute, you can find capital A. After that you can substitute, you can find small a1. Small a1 is 5 times of a naught, so you need to find 5 plus 2, which is 7. Next question, you can pause and you can read the question. The question says, a small solid ball of density rho naught is held inside at a point A in closed cubical container of side length L filled with ideal liquid of density 4 rho naught. So ball density is rho naught, liquid density is 4 rho naught. So buoyancy will be more than weight, right? If it is not accelerating. Now if the container starts moving with constant acceleration a naught horizontally and the ball is released from the point A simultaneously, it has been observed that the ball hits the point Q after a time t naught. So point Q, this corner from the middle. Okay, and the given key is wrong in the paper. Hopefully someone must be asking for correction. So this is the actual key. So first of all, suppose the container is not accelerating. If the container is not accelerating, how many forces will be acting on the ball? Its own weight, density times volume times g, apart from that buoyancy, right? Because there is a pressure difference. When you go down, the pressure difference will be rho g h, right? So lower pressure will be more than upper pressure, so there will be buoyancy in the upward direction, which will be given by density of the liquid into volume into g. If the pressure difference is rho g h form, then the buoyancy will be of the form density of the liquid into volume into g. Now when it is accelerating, what will be the pressure difference? If you take any small element of the liquid, see, if you take vertically, the extra pressure is coming out to be rho g h form. If the extra pressure is of rho g h form, then the buoyancy will be of the form rho into v into g. Now similarly, if you take some horizontal element, extra pressure will be of the form rho a h, if this h. If extra pressure is of this form, then the buoyancy in this direction will be, extra force in this direction will be rho L into V into A, right? So this is the buoyancy coming into picture because of the pressure difference horizontally. This is the buoyancy coming into picture because of the pressure difference vertically. Generally you need to find what is the resultant buoyancy and you have to take the components, but this also works, right? Because of the pressure difference along vertical, there will be this buoyancy. Because of the pressure difference horizontally, there will be this buoyancy. Now you need to find when it will hit Q. Now the important thing is container is moving. So if you are observing from ground frame, you need to observe like container movement at the same time like this ball movement also. So let us try to observe from container. When we are observing from container, apart from this normal forces, inertial forces, there will be pseudo force coming into picture, right? Pseudo force. How much will be pseudo force? Mass times A naught. Mass is rho naught into V, mass times V naught. So these are the forces acting on the sphere when I am observing from container frame. This is weight, this is buoyancy because of the pressure difference in vertical direction, this is buoyancy because of the pressure difference in the horizontal direction, this is pseudo force. So what will be the net force? Net force will be 4 minus 1, 3g. Net force will be 3, okay, net acceleration, I found net acceleration. Net acceleration will turn out to be 3a naught, 3g and 3a naught. Now if it is hitting Q, the meaning is vertically it is travelling how much distance? L by 2, horizontally it is travelling L. So horizontally half a t square equal to L, vertically half a t square equal to L by 2. So you can take the ratio, or yeah, two equations to unknowns, you can take the ratio, you can get a naught, substitute a naught back and you will be getting t naught, right? Next question, you can pause and you can read the question. The question goes like, there is a system of 4 conducting parallel plates A, B, C, D. Plates A and C are connected to each other with the help of metallic wire, and plates B and D are connected to the ground with the help of switches S1 and S2. Distance between the consecutive plates is D. Initially the plate A and B are having charge Q naught each, and plate D is having charge plus 2 Q naught at t equal to 0. Switches S1 and S2 are closed simultaneously. Then the correct options. This is the initial given figure. This is the figure I have drawn after grounding. Now after grounding, outside charge will become 0. So I think I have that explanation in revision class. If you have watched it, you will be mostly like okay with it. And this is grounded, so this potential is 0. This is grounded, so this potential is 0. I am assuming this plate potential is V. So this is connected by a wire, so this potential is also V. Now outside charges are 0. Now I will be assuming this charge is X. If this charge is X, then this will be minus X, right? Now you see this potential difference is same as this one, is same as this one. So if this I assume it as X, then this one also will turn out to be X. So if I assume this as X, then this will turn out to be X, and at the same time this will also turn out to be X, because this capacitor is between V and 0, this capacitor is between V and 0, this capacitor is between V and 0, right. X I will be getting, then minus X, then I think you can see that all the potential, there are 3 capacitors and parallel to each other. Anyway, I am not going to do that, I am just checking like, okay, what is the charge on this A and C? Summation of charge on A and C is 3x. Why I have done that is because there is no way for A and C for the charge to go. The charge on A and C must be remaining same throughout the charge on A and C combinedly must be same throughout, because it is isolated, right? It is how much Q naught. But I can't say the same thing about B and D because they are grounded. Ground can give the charge or take the charge. So summation of charge on A plus C initially is Q naught, finally also it must be Q naught. So 3x equal to Q naught, so x equal to Q naught by 3. I will be drawing the same figure by substituting x equal to Q naught by 3. Instead of Q naught by 3, I will be substituting 1 by 3 so that it will be easy to write for me. So Q naught by 3 minus Q naught by 3 minus Q naught by 3, Q naught by 3, Q naught by 3 minus Q naught by 3. Now I think you can see it easily. Initially the charge on this one is plus Q naught, now it is becoming minus 2 Q naught by 3. So plus Q naught went, I mean I can say like ground has given minus Q naught and minus 2 Q naught by 3, or else I can say like positive charge kind of went. How much positive charge kind of went? Q naught plus 2 Q naught by 3 went, so it became negative 2 Q naught by 3. So Q naught plus 2 Q naught by 3 went, it will become 5 Q naught by 3 went, right. Now similarly in the second case, this charge is 2 Q naught initially, now it became Q naught by 3. So 2 Q naught went, apart from 2 Q naught the extra Q naught by 3 went. So 2 Q naught plus Q naught by 3, which will be 7 Q naught by 3. You can pause and you can read the next question. The question says, an insulated sphere with a dielectric constant K, where K is greater than 1, of radius of R, is having a total charge plus Q naught uniformly distributed in the volume. It is kept aside, okay, it is kept inside a metallic sphere of inner radius 2R and outer radius 3R. Whole system is kept inside metallic shell of radius 4R. The metallic sphere is earthed as shown in the figure. Spherical shell of radius 4R is given a charge Q naught. Consider electric field versus R graph for R greater than 0 only, where E and R represents electric field and radial distance from the center. Then choose the correct options, right. So this will be the charge redistribution. The charge induced on the inner surface of that metallic sphere will be minus Q naught. Now it is grounded to earth, so I can't say what will be the charge outside. If it was not grounded, I would have said outside charge will be, this charge will be Q naught because the total has to be 0. But when it is grounded, I can't say anything, so I will be taking it as x. If this is x, this will be minus x. If this is minus x, outside charge has to be Q naught plus x, because the total charge on the outer sphere must be conserved because it is not grounded. No one can give the charge to it, right. Now I have represented this distance. This is R, this R, 2R, 3R, 4R, and till infinity, right. Now field due to this one, it will be 0 when you are talking here. If you are talking about field at some point here inside, if you are talking about some point here, the field will be because of only this charge, right. And you can get that as like easily, you will be getting it as KQ by R cube into R form, right, or else I must have said like it must be of some constant into R, But yeah, if it is like if it is a dielectric of dielectric constant 1, we would have done like normally, but its dielectric constant is K. So okay, instead of K, I will be calling it as epsilon, because K I will be using it here, right. So if there is dielectric of dielectric constant 1, then you will be getting KQ by R cube into R, right. But here it is dielectric constant epsilon, right. So I will be getting by epsilon, right. Yeah. So the electric field will be, okay, this value will be how much? 1 by epsilon times of this much. Just inside the magnitude will be this much, just outside the magnitude will be K Q by R cube into R. Anyway, that has nothing to do with the question much. I think it has something to do with the question. Yeah, fine. So So the field here will be KQ by R cube times of capital R. Okay, and I can select it will be KQ by R square just inside it will be KQ by R square, just outside it will be KQ by R square if the dielectric constant is 1. But if the dielectric constant is epsilon, then just inside the field will be this much, 1 by epsilon times of this much, which will be less than just outside. So when you try to see, it will be linearly increasing to some value, but just outside the value will be obviously more than this value. Now this value is this much, this value is this much. So just outside its value will be little more. Just outside its value will be little more. Thereafter the field will be because of only this charge. The field because of this one will be 0 in this region. The field will be because of only this charge, and it's kind of like when you are talking about point outside, you can replace this entire thing with a point charge here. So it will be decreasing. Now after this, what will happen? It is metal, right? Metallic conductor, right? Inside the material of the conductor, generally we will call it as meat of the conductor. So there the field will be 0. Now after this, when you want to find the field in this region, field because of these two will be 0, field because of this combination will be 0, there will be field because of only this x, Now the thing is, we have to find whether x is positive or negative. For that, what I did here is, it is grounded, right? So this potential I made it 0. So potential here will be because of these three charges, potential due to these two charges will be 0. You can watch the revision video why it is if you don't understand. So potential due to these two summation is kq0 by 4r, potential due to this charge is kx by 3r. So when you calculate it, you will be getting x is negative charge. So basically x is negative. When x is negative, the field here will be attractive, so it will be negative, right? So and it will be decreasing in magnitude. After that, you can see when you are talking about this region, field due to this combination is 0, there will be field because of only this one, and that value is how much? It is positive, q0 minus 3q0 by 4, which is q0 by 4. So it is positive. You can replace this entire thing with a point charge q0 by 4 at the center, and the field will be something and it will be decreasing. Now you can see discontinuous, right? Next question, you can pause and you can read the question. The question says, L-shaped conducting rod ABC is lying in xy plane and moving with the velocity v0 I cap plus 3 v0 j cap as shown in the figure. There exists a non-uniform magnetic field which depends on x and y coordinate given in the equation, where b0 and L0 are positive constants with proper dimensions. If Vp minus Vq represents the motional EMF induced between P and Q, then choose the correct options. Right? So velocity is given as v0 I cap plus 3 v0 j cap. Now, if due to this velocity v bar cross b bar, like you can see v bar cross b bar dot dl, due to velocity along x axis, there won't be induced EMF along AB. There won't be induced EMF along AB, but due to that x component, there will be induced EMF along BC. Now, due to y component of velocity, there will be induced EMF along AB, but there won't be induced EMF along BC. So I will be splitting it into two components. I will be looking at it like motion along x axis and motion along y axis. Okay. So if I look at the motion along y axis, 3v0, it is moving 3v0, v bar cross b bar dot dl bar, it will give me the, okay, positive charges will try to go this way, right? Generally negative charges will move, negative charges will be going this way, but I will be trying to visualize it like positive charges will be going this way. So higher potential, lower potential, right? So how to find that v bar cross b bar dot dl integration? So you will be taking some element, and you will be finding what is the induced EMF in that element, and you will be integrating. Now if I take some element at a distance x, when its x coordinate is x, now look at this thing, y coordinate is L0, so if I want to find the magnetic field, y coordinate is L0, no matter which point I take on it, y coordinate is L0. Now the only thing which varies is this x, right? So when the x coordinate is x and that small thickness is dx, the magnetic field will be how much? Magnetic field will be this much, b0 by L0 into x plus b0, because I substituted y is L0, b0 by L0 into L0 will turn out to be b0, right? So this is the magnetic field at some element which is at a distance x. So V bar cross B bar dot dl, right? V bar cross B bar dot dl. Now you need to integrate from where to where? X coordinate is L naught to 3 L naught. So you will be getting 18 V naught B naught L naught, and V bar cross B bar dot dl bar. This will be higher potential, this will be lower potential. So A minus B will be this much. Now similarly do the same thing for this one. So due to motion along x axis there will be induced EMF. So V bar cross B bar dot dl bar, right? And for this entire thing x coordinate is how much? 3 L naught. So magnetic field will be how much? This much. Why I will be getting this much? Because I will be substituting x equal to 3 L naught. When I substitute x equal to 3 L naught, I will be getting magnetic field is this much for any y coordinate. V bar cross B bar dot dl bar. Again I have to integrate from y coordinate L naught to 2 L naught. Then you will be getting this much, and V bar cross B bar. So this will be higher potential, this will be lower potential. A will be higher, B will be lower, C will be higher, P will be lower. Then if you want to find the difference between A and C, you can subtract them, right? And you will be getting the required answer. Next question, you can pause and you can read the question. The question says, a highly thin conducting spherical shell of radius R0 is completely filled with water at 0 degrees. Outside surrounding temperature is minus T naught. Latent heat of fusion of water is L naught, and the thermal conductivity of ice is K ice. Assume the heat is flowing symmetrically in radial direction. Choose the correct options. You can get the last option easily. So all they are asking is what is the total heat released, right? So total heat released will be M into L, right? Because this will be going as, this will be converting into ice. So the heat will be released, right? M into L. M into L, you can directly get it. Now they are asking time taken. Now the important thing is, while freezing, what will happen? The outside layer will freeze, and so it's kind of like this structure will happen, right? At any some generalized moment. So this must be ice and this must be water. Now you can see like the flow depends on like what is the thickness of that ice, because ice will be having some resistance, right? So it's kind of like there is potential difference and there is some resistance in between. So heat flow, current flow, right? So I will be finding the resistance when water is of radius of sphere smaller. So I will be finding what is the resistance of this ice, so that I can see like at what rate the heat will be flowing. Resistance will be rho L by A. I will be taking some small element here. I will be taking some small element here. I will be finding this resistance and I will be integrating from here to here to get the total resistance. That small element resistance is rho L by A, and when I integrate from R to R naught, I will be getting the total resistance of that ice. When I know the total resistance of that ice, then I can find the heat current. Heat current is like V by R, or else T naught delta T naught by R by this one. Then, and what is dq by dt doing? This dq by dt is, if heat is flowing from inside to outside, it is making the ice spread further, right? Or else I can say like the next layer of water will be becoming ice. I can say dq by dt is dm by dt. This dq by dt will be utilized to make ice, right? Now this dm by dt I can write it as this thing, right? Because of this dm by dt, the radius of the water is reducing, right? So radius of the water is reducing, so negative sign will be coming into picture. Thereafter you have to integrate and you will be getting some generalized result, because I have integrated from 0 to R to 0, right? Now in the question they have given, instead of R, in one of the option they have given R naught by 2. Substitute R naught by 2, then you will be getting the answer for one option. Substitute R naught, you will be getting the answer for the other option. So basically the majority of the question lies in finding the resistance of the ice at some generalized moment and finding the heat given at that generalized moment, and because of that heat given, how much ice is getting formed. These are the 3 steps you need to follow in sequence. Next question, I think you can pause and you can read the question. I will be going with the solution. A is decaying and B is getting formed. So you know A equation will be Na equal to N naught into e power minus lambda t, and B equation will be N naught into 1 minus e power. Now again they have given like after 6 seconds it is becoming N naught by 8. So you can clearly see like it is becoming 1 by 2 cube. So this is 3 times of time period. So time period will be 2 seconds. So lambda will be log 2 by 2. Now you can substitute T1. At T1 it is becoming N naught by 5. So you can substitute, you will be getting T1. Now similarly at T2 it is becoming 9 N naught by 10. You can substitute, you will be getting T2. It's only math, you can do it. The next question, you can pause and you can read the question. I will be going with the solution. They are applying some force. So you need to find the acceleration. In order to find the acceleration, what we will be doing? We will be finding the mass first. Mass is You will be taking some small element, you will be finding the mass of that element, because the density depends on the density is not linear. I mean, sorry, density is not constant, it is linearly varying. So density times dx will be mass of that element. When you integrate, you will be getting the total mass till, okay, what I have done is I didn't find the total mass, I have just found the mass. I have taken this element, I have found this mass, thereafter I integrated from here to here, where this is x. Now if x equal to capital L, then that will be my total mass. If x equal to capital L, then that will be my total mass. If x equal to capital L, then that will be my total mass. Now if I know the total mass, F equal to ma, I will be getting the acceleration. Right, till here it must be okay. Thereafter they are asking what is the force at any distance x. What is the tension here? So this tension equal to this mass times of acceleration. This mass is how much? I just calculated it here. That mass times acceleration, you will be getting the required answer. They have asked to integrate this one with dx. That's again math, you can do it. Next question, you can pause and you can read the question. I will be just going to the solution. It's like you are applying some impulse. Because of this, what will happen? I can look at the motion like motion of translation of center of mass and rotation about center of mass. So center of mass of this system, this is one, this is center of mass of this rod, this center of mass of this rod, this is center of mass of this rod. So the net center of mass, okay, the center of mass of these two things will be here, 2m. So the center of mass of the system will be here, where this distance is a by 3 and this distance is 2a by 3. Now I will be looking at this motion like translation of center of mass and rotation about center of mass. Now impulse equal to change in momentum, impulse equal to change in momentum, total mass times v. So from there I will be getting velocity of center of mass. Now angular impulse about center of mass, how much it is? A into j, angular impulse A into j, that equal to IC into omega. Now I have to find moment of inertia of this system about this axis. So what I will be doing is, but it is easy for me to find moment of inertia about this axis because it is ml square by 12 plus ml square by 12 plus ma square, ml square by 12 plus ma square, ml square by 12 plus ma square, right? So but I can say moment of inertia about this axis equal to moment IC plus m into a by 3 whole square. IC plus m into a by 3 whole square will be giving moment of inertia about this axis, which is 3 times of m L square by 12 plus m a square, m L square by 12 plus m a square, m L square by 12 plus m a square, m L square by 12 plus m a square. So moment of inertia of system about this axis is this much, which you can write it as IC plus m into a by 3 square. From here I will be getting IC, I can calculate IC and I just substituted that IC back. Angular impulse equal to IC into omega, I just substituted, then I will be getting the required omega. That will give me the answer for 15th question. They are asking velocity of point P. Now point P you can visualize it like translation of center of mass and rotation about center of mass. So V will be along this direction and 2a by 3 omega will be along this direction. V 2a by 3 omega. You can substitute both the values, you will be getting the required answer. Next question, you can pause and you can read the question. There is nothing much in this question. It goes like, this is the only thing. According to the given information, this is a node, this is a node and this is a node, and there are only two particles between L by 6 and L by 3 which are having half of maximum speed. So it can be like, this is the only possible way. I mean like in future, like this will be going somewhere here. It will be becoming flat and after that it will be like, that's how you will be representing stationary wave, right? I have just drawn only one, don't misunderstand like it is traveling wave, it is a stationary wave itself, node, node, node. And again they have given some information like between 0 and L by 6, again there are only two particles. So this is the only possibility. Once you understand this is the possibility, now from the given graph, they are saying given graph gives the slope at L by 3, slope at L by 3. Now slope negative, 0, positive, 0. Right, so slope is going from this position back to that position in time how much? In 2t. So in order to get the same slope back, it is taking how much time? 2t. So in order to get the same slope back, it is taking how much time? 2t. The meaning is time period of this thing is 2t. After 2t you will be getting the same slope again. So 2t will be the time period. And how many particles are in phase between 0 and L by 6? All these particles are in phase. So when this particle go to extreme, this particle also goes to extreme. When this particle comes to mean position, this particle also will come to mean position. All the particles are in phase. So option A will be correct, right? Thank you.